Welcome to the new Percussionaire.
I'm Mark Bailey, President and CEO of Percussionaire Corporation. I am pleased and excited to announce the dawning of a new corporation. Out of our original roots at the Dr. Forrest Bird Center, Percussionaire has evolved into a very modern and forward-thinking company, introducing a concept of ventilation never fully advanced before.
State-of-the-art facility. New professional management team. Modern devices for the modern world. And changing the concept of mechanical ventilation. To many respiratory clinicians and pulmonary manufacturers, Percussionaire has been known for its most historic and storied past. Forrest Bird and Percussionaire revolutionized the concept of mass ventilation to the world with its introduction of the first small positive pressure ventilators. Yet, hidden in the depths of the research side of Percussionaire are devices that again not only create a new and progressive corporation, but again seek to change and revolutionize the way pulmonary support is done in the frailest and difficult to ventilate patient in our world. For many years, the concepts of conventional ventilation in pulmonary support has revolved around traditional pressure and volume ventilation. Flow has been a subservient dynamic to modulate pressure and volume in the conventionally ventilated patient. The need has been obvious: provide enough gas volume to meet metabolic demand, but control pressure enough to do no injury. For decades, these principles guided our development of pulmonary support devices and strategies. The key challenge is what happens in the severely underdeveloped lung or the diseased lung when you run out of surface area. Volume, limited by conventional time constraints, can no longer meet the consumption demand of the body. First, let's start with the basics and work up. IPV, intrapulmonary percussive ventilation. What is IPV? IPV is a highly effective therapeutic application of flow ventilation for the purpose of clearing out lung debris and infiltrates. IPV introduces short, sharp bursts of pulsatile gas through a patented delivery device to open, expand, and recruit a compromised lung. High-velocity gas moves through the smallest of airways, reaching the lowest consolidation. Gas flows through the accumulated debris and creating counter-current lift. This upward convective drive expands and recruits the lower airways. All this while providing the upward drive force to remove secretions very safely at the lowest levels of the lung. So, why is IPV so superior to other means? Only true IPV can deliver gas below the consolidation to create an upward drive. In the lower airways, fluids are at the bottom of the airways. Atelectatic areas are closed. With IPV, sharp bursts of high-velocity gas breaks through and expands those closed areas and fluid pockets to create a counter-current flow, expanding, recruiting, and clearing out the compromised area. Upward flow clears out and extracts the obstructing fluids. Small pulsatile pockets of gas are essential to flow safely down the smallest of airways, creating the continuous flow necessary to move secretions out of the lung. The key to the safety of IPV is the remarkable phasotron. To achieve adequate airway clearance and recruitment, short bursts of high-velocity gas must be achieved to clear and recruit. The phasotron is an instantaneous pneumatic clutch that protects the lung from injurious pressure at all times.
Hi, so this is our multi-lung display, and this will give you some of the properties of the flow characteristics of the VDR. As you can see for this display, we set the VDR up with a rate of 15, percussive rate of 500, and a PEEP of about 7. And for the rest of this display, we don't adjust the VDR at all. It stays the same. When you get over here to the multi-lung, you can see that this would be an example of a heterogeneous lung. We've got areas of adult lungs on here. We've got areas of smaller volume. Consider this a lung maybe that's wet, edematous, a disease process going on. You can see we also have areas over here as well. As the flow is being delivered down the central part of the airway, and then it's coming back in its transhelical loop, you can imagine the speed of that coming through here and returning is lower than somewhere that's much smaller. This is disease. It's even faster in a loop right here. This is not being distended nearly as much, but the speed of that loop is going to be much, much faster. So you can see in a heterogeneous lung where you have all of these different components, you've got variable speeds of that loop. But one of the advantages is while you're recruiting in areas like this, you're not over distending these parts of the lung. It keeps from getting a lot of value trauma or barotrauma. But you can see also, if you can go all the way down and accommodate even these smaller areas, you can take these same settings and go all the way to a lung this size. Here you can see it's not going to over distend this, but the speed of that loop, that counterflow loop going through there is going to be very, very high. This also is a good display of the amount of kinetic energy that's being involved in your airway exchange. This is very important and a very specific attribute that is exclusive to Percussionaire products.
What about pulsable flow ventilation in the sickest of patients? IPV is the simplest of applications of flow ventilation for airway clearance. Going much further, it is the diseased and underdeveloped lungs that need the greatest amount of acute support. Intermittent airway clearance is necessary. However, total ventilatory support for the sickest patients is the overwhelming need. The best of the conventional ventilators run out of capacity over time. The principles of flow ventilation are simple. Why not oxygenate and ventilate the lung over the entire period of the breathing cycle? If gas can flow constantly across the alveolar capillary interface, the greatest amount of adsorption can occur.